All right, so this week is our last week. Congratulations. This week goes into some forecasting methods. This is probably one of the most commonly used form of statistics. We actually use forecasting methods across all types of industries, but particularly in the healthcare industry. We can use forecasting methods for supplies, like how often we need to reorder supplies, what's the demand going to look like. We can anticipate staffing needs based on forecasted volume of customers or patients. We can use forecasting methods for a lot of different items. When you think about forecasting, we typically most often think about weather forecasting. It's no different. It's looking statistically at trends in the past to help us identify what our next or what the likelihood of something occurring is for the future. So this really gives us a lot of insight into what we can anticipate coming up. And there's a lot of different methods to forecast. We're going to go through a few of them today. Each method varies depending on the error, and so we look at error to determine which is the most accurate. The lowest average error, for example, is going to be the most accurate method to forecast. So sometimes you may need to forecast data through a variety of different formulas and tools to determine the most accurate method going forward, and then you can utilize that method to forecast the next few periods. So in this first problem, we have two different sets of data. We have unemployment and inflation, and it gives us the month and the year that data was reported. And what we're looking to determine is what unemployment and inflation would look like for the next period, which would be the December 2010 period. And the first method we look at is this 3-month moving average. And a 3-month moving average, quite literally, is the average of the prior 3 months. So we would see this trend line as sort of a rolling trend line, where the prior 3 months would look very similar to the 4th month. So we take in Excel, we can just do average and click on the prior 3 months. So you'll notice we don't start until period 4 because these 3 periods, we don't have 3 periods of data before that. So we always use our existing known data in order to help us determine the forecast for the next period. So we use average for that 3 months, and then average of the 3 months prior here. So you'll see it keeps moving down. So once you put this in Excel, you can drag it down and copy it all the way down to December 2010. From there, we need to calculate the error. So the error is what we would have forecasted versus what actually was. And again, this is why we use existing data to help us identify trends and forecasts for future data. So we take our absolute value, and in Excel it's equals ABS. And the reason we use absolute value isn't positive or negative. We're just looking at what the difference was between our actual data and our forecasted data. We don't care if it was to the right or left of the number line. We just want to know what that error is. So we use absolute value equals ABS of the actual data minus the forecasted data. And then again, we carry that down. And then we use equals average to average out our error. So our average 3-month moving average error is 0.26. Notice we don't consider our forecasted data in our error, and that's because we don't have actual data to compare. This is what we're actually forecasting. So we can say that we can forecast December at 9.67, give or take 0.26 for an average error. And then we can do the same thing for our 3-month inflation. So you'll notice that on the 3-month inflation column, we're taking the average of the 3 months prior, and again carrying that down. And we do the same thing for our error, the absolute of the actual minus the forecasted amount. And again, here's our forecasted for December, and our average error, again, doesn't include our new forecast of those data sets that we knew. The second method is called exponential smoothing, and there's really 2 ways to do this in Excel. The first way is to enter in the formula manually, and in exponential smoothing, it requires 2 months of data prior. The first month, it's just equal to the second month is just equal to the first month of actual data. That's it. So it will always be whatever this first month is going to start our second month. Then our third month, we can start to use the formula. And that's why we have to skip the first month, because we don't have the month before that. So on our third month, we're going to take our alpha. And in this case, the problem states that our alpha is 0.6. And multiply it by our actual. Then we add our 1 minus alpha, so the difference, and multiply it by the forecast. Both of those are for the month prior, or the period prior. So again, that's why we can't use the first month, and why the second month has to just equal the month prior of actual data. So alpha times the actual plus 1 minus alpha times the forecast for the prior period. And then we can carry that down. And we do the same thing for our error. We start with our first set of data that we do know and have an estimated forecast for. And we take our absolute of the actual minus the forecast. And then we carry that down. So in this case, comparing these two, they seem relatively close, but when we consider that it's a small number in the forecast to begin with, this makes a pretty big difference. So we can say that using exponential smoothing is the most accurate method to forecast unemployment. So again, we can do that same format for our inflation. We can also use our data tab in Excel and use data analysis. And if you don't have the data analysis tab in your Excel, you can go to File Options, and I'll show you where to do that next. But we use the exponential smoothing function and say OK. And the input range is just going to be your actual data. So in this case, my input range is the inflation. The dampening factor in Excel is the 1 minus alpha. It is not the alpha. So we're going to put 0.4. And then our output range, we're going to start this here. And we're going to say OK. And it automatically pre-fills in the equation for us. So you'll notice this one equals the prior month's actual data. And this one equals the prior month multiplied by alpha plus the prior month's estimated or forecasted times the 1 minus alpha. So it automatically puts that formula in for you. And then we're going to calculate our error the same way. So we take the absolute value of the actual minus the forecasted. And in this case, when we're looking at inflation, both methods are similarly have a similar error or the same error. So if we were going to continually forecast unemployment and inflation at the same time, we would then go with exponential smoothing because it's the most accurate for unemployment and there's no difference between inflation methods. All right, so the next method we're going to look at is something you probably have seen in algebra classes before, and that's linear regression. You may not have known that you were doing linear regression. And in linear regression, we're following the equation y equals mx plus b. So you may have, or the slope line, the trend line of that particular line. So this is something you may have seen before, y equals mx plus b. And there are two ways, again, that we can get this forecast for regression. We can use the y equals mx plus b, and we're going to do equals slope. And it's asking for our known y's and our known x's. And what we look at when we look at regression analysis is, does one thing predict or cause another to happen? So in this case, does the number of does the period number predict or cause y to increase? So the best way that I remember it is, does x explain y? So when I'm trying to remember x's and y's, for example, let's call this months, and let's call this sales. So we don't know what x and y is because they're not clearly labeled x and y, but we can still determine x, y. We're trying to determine if every month sales increase. So does an increase in the number of months occurring cause an increase in sales? Does x explain y? So now we can do our slope. We take our known y's, so does it explain y, and our known x's. And you'll see here, and this is a different output that I'm going to show you how to get here in just a minute, but you'll see that my slope here equals the same slope that Excel provided me. So I know we're on the right track. The next thing we need is our intercept. And in Excel, the formula is equals intercept. And again, it's asking for our known y's and our known x's. So now we have our y equals mx plus b. And so the formula, when we're using the Excel output, we can say b is our slope, m is our intercept. So our forecasted sales is going to equal, and we're going to retype this equation in here, equals our intercept times our x plus our slope. And anytime we want to lock down a cell so that it doesn't move on us when we carry forward the formula, we can use F4, and it puts those dollar signs in for us. Oops, and I got our equation backwards. So, correct this. go. Now we're back on the right track. So we take our y equals, so we're just going to type in equals in Excel, parenthesis, because we want this to happen first. We're going to take our slope, multiply it by the number of months, and then we're going to add in our intercept. And then we can carry that down. And for our moving average deviation, or moving absolute deviation, again, we're just using our absolute value of the actual minus the forecast. So our average mean absolute deviation uses equals average, and then we're going to take our total too to get our total deviation, and we want to make sure that we're not including our average in there. I'm going to correct that formula there. Our mean squared error simply takes our error and to the power of 2. So we take our actual minus our forecasted to the power of 2. And then again, we're going to average, and then we're going to total. Okay, so the next piece that we're going to look at is the exponential trend line. Now, this is a little bit different than exponential smoothing. This is using an index key in order to create some form of trend line. Again, similar to a regression trend line, but a little bit different. So this requires a pretty complicated Excel formula. So the first thing we need to figure out is what our exponential index is. And I've put that formula here for us. And it requires logarithms, so we use exponent, exp, parenthesis, index, parenthesis, linus, parenthesis, log, which is ln, parenthesis, and then we select our known y data, comma, select our known x data, parenthesis, times 1, comma 2. And then you have to end 2 parentheses to make sure they all line up. So I know that's a really complicated formula, and I don't expect anybody to memorize that formula. Just keep it handy in case you ever need to do an exponential trend line. And then our next factor is our secondary index, or B. And here I put the formula for the B, which is, or slope index, sorry. So our slope index, and then we have our index, linus, ln, and then our known y's, comma, our known x's, comma, 1. So once we complete that, then we can do our exponential trend line. And you'll notice, again, I've locked down these functions here. So we're doing our, So the first thing we take is our C times the exponent of our B times our month. And then we can carry that formula down. Again, as long as you lock down these 2 cells so that they don't move, you can copy and paste the formula all the way down. And then we do our mean absolute deviation and our mean squared error the exact same way we did for our regression. Now I'll back up a little bit and show you how to do regression analysis using our data analysis in Excel. So when we do data analysis, again, if you don't have that, wait till the end of this and I'll show you how to add that to your Excel. And now we're going to choose regression. And we say OK. Again, input our known y's, input our known x's, Then it wants our output range. I'm going to ask it to go to a new worksheet so that it doesn't override all of the other typing that I have here. But you can certainly put it on the same worksheet. Just simply click the output range there and click on the cell where you want it to start. I'm going to say OK. And here's where that summary output was created in Excel. So here's our intercept and our slope, just like it was over here, intercept and slope. All right, so let's say you don't have the data analysis tab and you want to add that in. We're going to go to File, Options, Add-ins, and we're going to do Excel add-ins down here at the bottom. So if that isn't in there, make sure Excel add-ins is in there and click Go. And you want to make sure that this analysis tool pack is checked. Don't worry about these other checks that I have. These are other items that I work with for other things. But you just want to make sure this analysis tool pack is checked. And say OK. And that puts your data analysis in here for you. So again, you'll find that under your data tab.